So now we are going to look at mixtures, still under chapter 6, elements, compounds and mixtures. So specifically, let's look at mixtures. What is a mixture? A mixture is a substance which consists of two or more elements or compounds, and they are not chemically combined together. And we have various examples of mixtures. For example, I can combine sulfur and iron, as we have already seen. You can have a mixture of salt and water, a mixture of salt and sand, a mixture of water and alcohol, chalk and water, air itself is a mixture, and so many others. So as you are home, come up with any mixture that you can be able to look at. So what are some of the differences between mixtures and compounds? Mixtures can be separated by physical means, for example, filtration, by magnetization, whereas compounds cannot be separated by physical means. You cannot get a compound and then you separate it by simply sorting. For example, I cannot separate a compound of iron and sulfur by sorting. Two, mixed physical properties of mixtures, for example, color and density, are the average of the constituent substances, whereas in compounds, physical properties of compounds are quite different from those elements that are present in them. The energy is not usually given out or absorbed when a mixture is formed. For example, when they are mixing iron and sulfur, we didn't need energy, we just simply got iron and sulfur and mixed the two. But then when we were forming the compound of iron 2 sulfide, energy was required. We had to heat the mixture of iron and sulfur to form the compound of iron 2 sulfide. Then another difference is that in mixtures, their composition is variable. The substances can be combined in any proportion by mass. For example, I can get 2 grams of sulfur and combine it with 1 gram of iron. But then when we come to compounds, this composition is not variable. The elements are combined in definite proportions by mass. After I have made a compound, I cannot know that now sulfur is this mass and then iron is also this mass. I believe when you watched the video investigating the reaction between iron and sulfur, you must have come up with these different properties that I've mentioned here. So types of mixtures. We have 3 types of mixtures, that is the solid-solid mixtures. For example, if I combine beans and maize, that is a solid and solid. If I combine salt and sand, that is a solid and solid. Iron and sulfur, that is solid, and so many others. Then we have solid liquid mixture. I have a solid, for example, sand, and I've dissolved it in water. Then a liquid mixture, for example, I have ethanol and I have dissolved it in water. I'll begin with the solid mixture. The solid mixture, depending on the type of mixture that you have made, but we have different ways that they can be separated. One of them is by sublimation, another one magnetization, 3 by sorting, 4 by dissolving in water, and then you carry out filtration. All those methods of separation will depend on the type of mixture. I'll begin by looking at the different ways of separating the solid mixture, and I'll begin with sublimation. Sublimation is a method used to separate a mixture of 2 things where one sublimes and the other one cannot. For example, if I have a mixture of iodine and sand, and then I heat it, iodine will sublime and change to a gas, whereas sand will remain in its solid state. So I'll be able to separate the two. Here is a picture to show you what will actually happen. The mixture of iodine and sand is put in a beaker, and then we have an evaporating dish which has covered the top with some water, of course, to allow cooling of the vapor as it gets to the bottom side of the evaporating dish. and then we are heating gently using a Bunsen burner. So you can see that the purple vapor of iodine is evaporating and it cools at the bottom side of the evaporating dish. So time will come when in the beaker we shall remain with only sand. So that method is known as sublimation. If I have not used iodine, there are other substances that can sublime. For example, ammonium chloride. I can also mix ammonium chloride with sand, or I can mix ammonium chloride with table salt. Then we also have anhydrous aluminum chloride, we have iron 3 chloride, and also benzoic acid. All those substances sublime, so when they are mixed with another solid, the method that can be used to separate them is sublimation method. Then we also have another method of separating a solid-solid mixture by magnetization. This has been seen when we wanted to separate a mixture of iron and sulfur using a magnet. We saw that the iron was attracted by the magnet, but then the sulfur could not be attracted by the magnet. The reason is simple, is that iron does not have the magnetic properties, sulfur lacks magnetic properties, whereas iron has the magnetic properties. So here, this is a brief picture to show you the sulfur, the iron, then the mixture of iron sulfur filings with the sulfur, and then the separation. You can see that the magnet is actually attracting almost all the iron from the mixture. Then another type of mixture is the solid liquid mixture, and these can be separated by either filtration, decanting, or crystallization and evaporation to dryness. I'll begin with filtration. Filtration separates insoluble solid from a liquid. For example, if I mix sand and water, then I pour it through a filter paper. Usually a filter paper has very tiny holes that cannot be seen with our naked eyes. So you find that the large solid particles of sand cannot pass through the tiny pores of the filter paper, so they are trapped and they remain as the residue, while the tiny liquid particles will pass through and they are known as the filtrate. Here is just a simple picture to illustrate that. We have a mixture of iron, of salt, we have a mixture of water and sand, and then we are powering it on a filter funnel containing a filter paper. So the water, you can see it is in the beaker and it is colorless, which is the filtrate, and what will remain in the beaker where the mixture was will be the sand, which is the residue. Then another method of separating the solid liquid mixture is by crystallization and evaporation. And what do we mean by crystallization? Separation of dissolved solid from a solution and you form crystals. Then evaporation to dryness is separation of dissolved solid from a solution as crystals. For example, water evaporates, leaving the salt crystals behind. So you can see here, we shall begin. They are labeled with numbers. We have the impure solid in a dissolved solvent. You can name that impure solid as the sand, and we have the stirring rod to stir the solid. Then evaporation. So we have process 2 where we have crystallization and it is being poured on the evaporating dish. Then from the evaporating dish, you can see still step 2. The solution is heated to evaporate most of the solvent. To turn the process to evaporation to dryness, continue heating until the salt is obtained. Then step 3, the hot solution is allowed to cool. The solid appears as cool crystals. And step 4, the cold solution is poured off to obtain the crystals. The crystals may be dried by pressing them between sheets of filter paper. So that one just shows us a summary. That means that there I had sand dissolved in water together with common salt. However, I could begin by also decanting to get off the sand, and then the solution will go through that process from 1 up to 4. Common salt and sand are placed in a beaker and water is then added. The mixture is warmed gently while stirring until the salt dissolves completely. The salt dissolves but sand does not dissolve. The solution is then filtered. After filtering, the salt solution is obtained separately from the sand. Then the salt solution is then poured into an evaporating basin. The water evaporates when the salt solution is heated. It evaporates completely, leaving salt crystals behind on the evaporating dish. This is called evaporation to dryness. So those are the steps that have been summarized in the above diagram. We still have separation of solid-solid mixtures by decanting. Decanting, this method can also be used to separate a mixture of sand and salt in water. Yes, we can just try it out. Even you can also do it when you are home. Put a mixture of sand and salt in the beaker and then you add water. Stir the mixture. Salt will dissolve in the water but sand will not. Leave the beaker to stand for a few minutes for the sand to settle. The sand will settle on the bottom of the salt solution. Pour off the salt solution carefully without disturbing the mixture. The sand will be left at the bottom of the beaker. Then evaporate the salt solution to dryness. This is still the same as what I have already explained. So you can see we have the mixture of sand, salt and water, and we are pouring off the water so as to remain with the sand in the beaker. The sand will remain at the bottom of the beaker and is known as the residue. Then the salt water solution poured into another beaker and it is known as the filtrate. Then another type of mixture is the liquid-liquid mixtures. There are two types of liquid-liquid mixtures, that is the immiscible liquid-liquid mixture, also known as the heterogeneous mixture. Then the miscible liquid-liquid mixture known as the homogeneous mixture. And these ones are separated depending on the type of mixture that is being formed, depending on the liquids that have been mixed together. I'll begin with the separation of heterogeneous mixtures using a separating funnel. You can have very many examples of heterogeneous mixtures, for example, water and paraffin, water and oil, water and mercury. So, to separate two liquids that don't mix uniformly, we need to use a separating funnel. This method is used for separating immiscible liquids. So what are immiscible liquids? Immiscible liquids are those which don't mix at all. Such liquids separate into distinct layers according to their densities, and we can also call them heterogeneous mixtures. For example, if I have paraffin, mixture of paraffin or oil, and I put n of those two in water, then pour in a separating funnel. Shake vigorously and allow to settle. Which of the two has a higher density than the other? We see that water has a higher density compared to paraffin. Therefore, water separates to the bottom and the paraffin to the top, making the different layers. The tap is opened and the water layer runs out first. So we need to close the tap and put another container where paraffin will be collected. Open up the tap to collect the paraffin in another container. So here we have a set of apparatus to show what I have been talking about. This is a mixture of oil and water, and they have been put in a separating funnel. I think you can see the two distinct layers. The oil is less dense, therefore it is on top, whereas the water is denser, therefore it is down. So you get a beaker and you open the tap. When you open the tap, the lower layer now, which is water, will flow out. When all the water has been able to flow out, close the tap so that the upper layer can remain inside the separating funnel. If you also want to remove it, you can put another beaker, open the tap, and you'll have your upper layer, which this time will be the oil. Thank you so much. We've looked at the different methods we can use to separate the solid mixtures, the different methods that we can use to separate the solid liquid mixtures, and we have also partly looked at how to separate a heterogeneous mixture. Thank you.